This is going to be our video for Unit 4, Day 5. So we've been working with fractions, using that to work with proportions, solving proportions by cross multiplying. Now we're going one step further and solving what are called rational equations. So rational equations are equations that have fractions with variables in them, and specifically the variables are in the denominators of the fractions. These are called rational equations. Again, rational has the word ratio in it. Ratio means fraction. That's where we get the idea. Rational equation, ratio, fraction. Equations with fractions. So we're going to go through a couple different ways of solving a rational equation, but relating to what we've just done, one you can do is combine terms on either side of the equal sign to create a proportion. So if you combine to where you have one fraction equal to another fraction, that's a proportion. Like we did in the video yesterday, you solve proportion by cross multiplying. Remember, when we're setting that up, we have to narrow it down to where there's only one fraction on either side of the equal sign. And then you solve just like yesterday by cross multiplying. So going back to what we did in the last unit, once you cross multiply, there's two types of equations we can be left with that we've learned to solve in here. You might either have a linear equation, or we'll get into the harder ones, we'll give you a quadratic equation after you cross multiply. So what we're going to go through is two different ways you can do this problem. So the first way is following the steps, and this is going to be the most like what we've done the last 2 days. So step one is simplify each side so there's only one term or one fraction on either side. Alright, so on my right hand side I have 8. That's already one term. Alright, I can even, if I want to write it as a fraction, write it as 8 over 1. But on my left side I have two terms. So I need to combine these. So these are fractions, combining, I'm adding them. That tells me that I need a common denominator. If my two denominators here are x and 2x, my common denominator could be 2x. So this first fraction is already over 2x. The other fraction, the way I would get to 2x is to multiply it by 2. It's 2 times x makes 2x. I'd multiply the top by 2 as well, and I have an equivalent fraction over 2x. So just like we've been doing all along when we add fractions together, we get a common denominator, add them together. So this one's going to be 48 over 2x equals 8 over 1. So now we're done with step 1. Step 2 is going to be to cross multiply. So I'll multiply the 2x by 8, multiply the 48 by 1. Remember, if there was more than one term in either the numerator or denominator, don't forget to distribute, multiply everything by everything. Last thing is we're left with a linear equation. 16x equals 48. So my last step is going to be to divide and solve this equation. And we get x equals 3. That's one way we can solve it, and that kind of plays on what we've been doing where we set up proportions and solve by cross multiplying. There's another way we can also do this same problem. So if we set this up again, another way we could do this and we did a little bit of this in the last unit, we can multiply this whole equation by a common denominator to get rid of it at the beginning. we can actually multiply this entire equation by a common denominator and get rid of all the fractions. So here, with denominators x, 2x, and 1, our common denominator would be the same as we had before. It would be 2x. So I'm going to multiply every term in here by 2x. So I do this first multiplication. I have 2x times 23 over x. Alright, so we can simplify since x and x are going to cancel out. It's just going to be 2 times 23, 46. Next I'll do 2x times 2 over 2x. So same idea here. We have 2x times 2 over 2x. Here I can cancel out the entire 2x, just left with 2. And then my last term, I take 2x, multiply by 8, and I have 16x. And then everything else from here is going to be the same. It's linear equation. 48 equals 16x. Divide by 16, we have x equals 3. So same answer, just two different ways we can do this problem. So one way is we can multiply by the common denominator at the beginning. We'll have no more fractions left, and then solve that way. So on the back of the page, there's some more examples for you to do. There's 4 problems in the practice section and 2 more examples. If you need some help working through the examples, let me know in class. I can come around and help you with those examples. But there's at least 4 practice problems you should be trying on your own, and making sure you're comfortable doing this whole process on your own. So the next section of notes is going to be a different kind of problem. It's going to be a rational equation, an application of that. So we take rational equations, actually use it for use it to model real life situations. So this one is called rate of work problem. So the setup for these problems usually is you have 2 people doing the same job. And sometimes you know how fast each one of them can do it on their own, and you want to find out how quickly they can do it together, or the opposite, you know, how quickly they can do it together. You want to find out how long it take one of them to do it on their own. So sometimes we don't want to know how long it will take them working together. Sometimes we want to know how long it will take each one of them working alone. Alright, and there's 2 basic equations that these are all based off of. One is that the amount of work you do is equal to the rate that you're working at times the amount of time you work for. It's a very simple equation. Work equals rate times time. The other one, for what's called a combined rate, which is when 2 people are working together, right, the combined rate would be 2 rates added together if the 2 people were working on their own. So as you're looking at these, you're probably wondering, why is this a rational equation? These don't look like rational equations. Well, the reason they're rational equations is because rates are usually expressed as fractions. And that's where we get into the rational equation. So we'll do one example of each type here, and then you have a chance on the back of this sheet. There's 3 problems. You can try some on your own after that. So read through this problem. Again, what we like to do when we read a word problem, talk about this in class some, they start at the end. So read the question first. So how long will it take them if they're working together? So since it says how long, that lets me know I'm looking for a time. And I can see that they're working together. So now I'm going to be starting with my equation. Work equals rate times time. Time is what I'm solving for. So that means somewhere in the problem I have to have the work and the rate. So first thing we'll look for is the work. The work is what they're actually doing. So here, they're painting a fence. How many fences are they painting? They're just painting one fence. Next thing we look for is the rates. Alright, since it's a combined rate, we're going to add the two rates together for each person. So Shelly can paint one fence in 8 hours. So that would make her rate 1 over 8. So she paints one fence per 8 hours. Second rate, Karen can paint that fence in 4 hours. So her rate would be one fence for 4 hours. So I can put that into the formula also. And again, time is going to stay there since that's what I'm solving for. So now we have a rational equation set up. We have an equation with fractions in it, and we're going to solve. So first thing to do is combine these fractions in parentheses. So to do that, we need a common denominator. So between 4 and 8, I can use 8 as a common denominator. Add them together. Now to solve from here, I can multiply by 8 to get rid of the fraction. And then last step would be divide by 3. So 8 over 3 would be the answer, but in this case, we want to put it in terms of time. So 8 over 3 would be the same as 2 and 2/3. This would be 2 hours and 40 minutes. Alright, and the reason we know it's 40 minutes is because 1/3 of an hour, which is 60 minutes, is 20. And 2 of those make 40. So one thing it's helpful to do once you finish one of these problems, the rate of work problems, is look back, make sure that your answer makes sense. If the two people are working together, it should take less time than either one of them individually. So if Karen takes 4 hours, the answer should be less than 4. Shelly takes 8 hours, so definitely less than 8. Now this other problem is the opposite. If we look into the last sentence, how long would it take Lysandro working by himself is what the question is asking. So it's how long again, so we know it's time. Now he's working by himself, so this is going to be an equation where we're working backwards to find time it would take Lysandro working alone. So we still start with the same equation. But in this case, we're going to have to actually split this into two equations. One's going to be the together equation, and the other one be an equation just for Lysandro. So together equation, we're going to do the same thing we did for first thing, what are they doing? They're doing homework. How much homework are they doing? Just one. One assignment of homework. So it says working together. It takes them 2 hours and 30 minutes. So for time, this equation takes 2.5 hours, so you can put that in as 5 over 2 or 2.5. What we have to figure out is their rate. So if we look back, we can see that Hannah can do the homework in 3 hours. So her rate would be 1 over 3. Since we don't know how fast it takes Lysandro, we don't know his rate. So again, in setting that up, we're just looking to identify each piece. So we have to identify the work that's being done. It tells us the amount of time that it takes. We can figure one rate out from the information given, and the other rate we're going to have to solve for. So at this point now, we're going to go ahead and solve this like a linear equation. So I can multiply everything by 2 to get rid of the fraction. And I can distribute the 5 or divide by 5, whichever. Then I'm going to subtract so I can solve 5x equals 2 minus 5 over 3. Need to work with the common denominator of 3. So it's going to be 6 over 3 minus 5 over 3 is 5x. 5x is 1/3. So my step's going to be to divide by 5. Remember, when we divide by fractions, we flip and multiply. So this will be 1/3 times 1/5, which is 1 over 15. Now we're going to put that back up here, make an equation for Lysandro, and solve for this time. So the work is still 1. We know his rate now is 1 over 15, and the time is what we're solving for. So now this is a one-step equation. We just solve by multiplying by 15. So the answer would be 15 hours. So these problems can be kind of tricky to read through, so what you want to make sure is try and identify each of those pieces. Try and see if you can pull out a rate, figure out what they're doing, or if you're given a time. So just try and identify each of those 3 pieces. That can help set this up. If you want to look for another video that explains this a little bit better, you can search for rate of work problems. And for the first part of the notes, you can search for rational equations. That's it for the notes, but there is 3 more of these on the back. So try and at least set these up on your own and try and work through it as best you can. If you have any questions, I'll be around. You can ask questions for to help you get through this.